Good morning to all. Today we'll be discussing about the thin cylinders third part, which is a part of theory of structures. So before going into the lecture, we'll just revise the previous class. So in the previous class you have learnt about what is maximum shear stress, and we have derived an equation for maximum shear stress, which is equals to PD by 8T. So, and further, we have solved some numericals on various types of stresses, that is hoop stress and longitudinal stress. And after that, I have given certain introduction to the type of strains which will be developing in the cylinders, like longitudinal strain, circumferential strain and volumetric strain. So if you revise it once, there are strains are of three types in thin cylinders. One is longitudinal, circumferential and volumetric. So generally these are denoted by epsilon suffix L, epsilon suffix H and epsilon suffix V. So the equation for calculation of the various strains, first one is longitudinal strain. As the name itself is the self-explanatory, strain in longitudinal direction. So that we can write as epsilon L equals to FL by E minus mu into FH by E. What is mu here? We'll see what it is. And this is the equation for calculation of strain in longitudinal direction. So here, in some cases or in some textbooks, mu can be written as 1 by m also. So you should not get confused if the question carries an value of 1 by m or mu one and the same. So here you can see, if we observe the formula, stress by E is, as you all know, Young's modulus of elasticity. So, and ultimately, as E is equals to stress by strain, which can be written as strain is equals to stress by E. So this thing we can observe in this equation. So as the strain is in longitudinal direction, initially we are getting sigma L or FL, from which we are subtracting the certain portion of hoop stress, and what is this mu, we'll see it later. So after substitution of FL value and FH value, as we know, FH equals to PD by 40 and FL equals to, sorry, this is PD by 2T and this is PD by 4T. So if we substitute these values in this particular equation, we'll get ultimately this value, which is sigma L equals to PD by 40 by E minus mu times PD by 2T by E. So after solving the equation, ultimately we'll get this following equation: PD by 4 times TE multiplied by 1 minus 2 mu. Right? So this is the equation to solve longitudinal strain value in a thin cylinder. Right? And next is circumferential strain or hoop strain or hoop strain. So just observe these two equations. Here we have FL as the first term and FH in the second term. In case of circumferential strain, just these two will get interchanged. So as it is a circumferential strain or in the circumferential direction, hoop stress will come initially, and from that value we will subtract certain portion of this value, longitudinal value. So we get circumferential strain value as PD by 4 times TE into 2 minus mu. So as I have mentioned, what is meant by mu? Mu can be written as 1 by m also. It is known as Poisson's ratio. So you should know the range of values of Poisson's ratio. It is -1 to 0.5. So Poisson's ratio will be having a range of -1 to 0.5. So epsilon V, nothing but volumetric strain, the third type of strain which we will be discussing. And in the last class I have mentioned how we get the volumetric strain because of change in diameter and change in length. So how we get this equation, the derivation we'll see in the next class. So for the time being, you just remember this equation, which is PD by 4 times TE into 5 minus 4 mu. So here mu is Poisson's ratio, or in case it can be written as like this also. In place of mu, you can write 1 by m, or simply like this, 4 by m. Like this also the equation can be. So if they give mu value as some 0.25, it is also equals to 1 by m. So here we need to substitute 4 into 0.25 like that. Okay, I hope it is clear. As we have seen, the equations for longitudinal strain, circumferential strain and volumetric strain, and earlier we have the equations for various type of stresses. Now we'll just try to solve a numerical which is based on the equations which I have mentioned just now. So if we go into the numerical, a cylindrical shell 3 meter long has 1 meter internal diameter and 15 mm metal thickness. So given is length is 3 meter, internal diameter is 1 meter and metal thickness is 15 mm. So calculate the circumferential and longitudinal stress induced and also change in dimensions of the shell. So if it is subjected to an internal pressure of 1.5 Newton per mm square, and the rest of the values take E as 2 into 10 power 5 or 20 into 10 power 4, and see here 1 by m they have given, which can be written as equals to mu value. So if we consider this as the cross section, rough cross section of the cylinder, they are given thickness and internal diameter. In my previous tutorial, if I mention the outer diameter as small d, in case if I mention like that, please correct it. It should be internal diameter. So what we need to calculate here? Sigma h, sigma l, and change in dimensions. So change in dimensions means delta d and delta l, because a cylinder has these two particular dimensions, diameter and length. So length of the shell is 3 meter, and you can convert it as into mm, as every other units are in mm. Diameter is 1 meter 1000 mm. Thickness of the shell is 15 mm. Internal pressure is 1.5 Newton per mm square, and E and 1 by m, which is nothing but mu. So we are familiar with this equation, circumferential stress or hoop stress, which is equals to PD by 2T. P is 1.5 and D is 1000. 2 is 2 times of T, which gives us a value of 50 Newton per mm square. And next come to the longitudinal stress, sigma L or FL, which is PD by 4T, 1.5 into 1000 by 4 into 15, which is 25, or in the short form, if we divide sigma h by 2 gives us sigma L. So now we got these two values, and now we need to calculate these two values. For that we need to calculate strains. So as we have seen the earlier equations for different types of strains, epsilon h is equals to PD by 2TE into 1 minus 1 by 2 mu, 2m, sorry, or it can be written as 1 minus 2 mu. So we have seen this equation here, right? So don't get confused. Equation can be written like in this form, or after solving or taking LCM we can write in this form also. Both are same, right? So PD by 2TE into 1 minus 1 by 2m, if we substitute these values, already we got PD by 2T as 50. So directly we can substitute that 50 value, and it should be divided by E value. E is 20 into 10 power 4 into 1 minus 1 by into into 1 by m. We can write this one like this, right? So 1 by m, he has given a value of 0.3, so that he has mentioned here. So if we solve this, we'll get a strain value of 0.0002125. This is the circumferential strain value, right? But he has asked different value. What is that? Change in dimension. So it should be delta D or delta H, not the strain values. So circumferential strain involves change in diameter, as we already seen in the previous lectures. So epsilon H equals to change in diameter by original diameter. So here we can write this equation as change in diameter equals to epsilon H into diameter, right? So the same is written here. So change in diameter is equals to epsilon H into D. Here we have epsilon H, this value, and D, internal diameter, already given, which is 1000 mm. So if we multiply these two, we will get a strain of change in diameter of 0.2125 mm. So this is our one of the answers, which is change in diameter. So this we have got now, and next is this. As longitudinal strain involves change in length, which is equals to delta L by L, which can be written as delta L equals to epsilon L into L. Now we need to know this value, because we already have this length of the cylinder value. So epsilon L, earlier we have seen the equation for longitudinal strain, which is PD by 2TE into 1 by 2 minus 1 by M. Okay, so PD by 2T is 50, and this should be here 5. Okay, and TE is 2 into 10 power 5 into 1 by 2 minus 0.3, which gives us a value of 0.0005, right? So this is epsilon L, and if we multiply this value into length of the cylinder, which is 3 meter or 300 mm, we will get a change in length of 0.15 mm. So these two are the ultimate answers which we need to find out, which is change in diameter and change in length. This type of problem is very important, as this involves all concepts which we have discussed earlier. So is there anything we need to find out in this problem? Calculate the circumferential and longitudinal stress induced, and also change in dimensions of the shell. So we have done this, and already we have done this as well, change in dimensions. So the only key thing is we need to remember this strain equations. And the next thing is we'll solve another numerical of similar kind. The air vessel of a submarine is having 500 mm external diameter and 10 mm thick. The length being 2 meter. So you need to observe here they have given external diameter. Okay, so it is capital D and thickness is 10 mm and the length of the vessel is 2 meter or 2000 mm. Find change in the external diameter and length. So find change in the external diameter and change in length as well. When subjected to internal pressure of 12 Newton per mm square, take E is equals to 2 into 10 power 5 Newton per mm square and mu is or 1 by m equals to 0.3. So these are the given values: external diameter, thickness of the well. So I have mentioned here they have given, the tricky in this question is they have given external diameter. So if you are bit negligent, directly you will substitute this 500 value as small d and will solve the problem, and ultimately will get the wrong answer. As it is then external diameter, we need to convert it into internal diameter. How we can convert it? So thickness is 10 mm and external diameter is 500. So small d should be how much? D minus 2 times of small t. So d is 500 minus 2 times of thickness of the cylinder or vessel. We'll get it as 480 mm, and here this is L, which is L equals to 2 meter or 2000 mm. P, E and mu values he has given already. So in the same manner as previous problem, initially we need to calculate sigma h, which is PD by 2T, and D here we need to substitute internal diameter, not external diameter, which is small d. So 12 into 480 by 2 times of T. Longitudinal stress PD by 4T, PD by 4T, you get as 144 and this as 288. Now we need to calculate hoop strain as the previous problem. Hoop strain sigma h is equals to PD by 2TE into 1 minus 1 by 2 m. PD by 2t we got 288. E as 2 into 10 power 5 and 1 minus 1 by 2 into 1 by m. We'll get a value of 0.001224. From this we can calculate the change in the diameter, which is delta D is equals to epsilon d into small d. So here we can substitute external diameter as 500 instead of 480 and again adding. We can directly calculate as the change will be common for both internal and as well as external. There won't be any change in internal to compared to external. So that's why we can directly substitute external diameter here. So 0.001224 into 500 gives a value of 0.612. So this is our change in dimension in case of diameter. So he has asked change in external diameter and length as well. So longitudinal strain, again we have an equation epsilon L is equals to PD by 2TE into 1 by 2 minus 1 by M. PD by 2T is 288 by 2 into 10 raised to the power of 5 into 1 by 2 minus 0.3. We'll get an equation value of 0.000288. If we multiply this epsilon L into length of the vessel, which is 2000, we'll get a value of 0.576 mm. So just you can observe these values, how much negligible they are. 0.6 mm means slightly more than half mm, right? So even though the cylinder or the vessel is subjected to such a huge pressure, there is a slight change, very slight change in the dimensions of the vessel. So this will help you to check your answers whether they are correct or wrong, because if you get more values like 225 mm or 5 mm like that, so that type of answers need to be checked once again, because there won't be that much changes in the dimensions. Okay, I hope after solving these two numericals you are familiar with this topic, as it includes almost everything till we have discussed: calculation of stresses, calculation of strains, and also after calculation of strains we have seen the calculation of change in dimensions as well. So if we just go through the summary of this tutorial. Till now what we have discussed. So in this class you have learnt how to calculate circumferential strain, longitudinal strain, change in length, change in diameter using various formulae. Circumferential stress you already know, and in this class we have seen epsilon h and epsilon l values. Also we have seen the value of epsilon v, which I'll explain in the next tutorial, the derivation of this epsilon v, which is volumetric strain, and we will solve some numericals also based on this volumetric strain in the next class. So it is better to you to remember mu values, as I have already given, -1 to 0.5. These values which are useful for you for various competitive exams, you can remember these values. The range of mu value, Poisson's ratio. Generally mu of 0 to 0.5, nothing but positive side of range of mu values, or of engineering materials will be having such values like concrete, steel, and any other wood and any other material which is used in construction purposes. And from -1 to 0, this range will be having for genetic materials. So there won't be any negative mu values in our engineering problems. So we are very much bothered about positive values, and there are many researches going on. What if the engineering materials or some other materials which are having negative side of values, which are from -1 to 0, and their applications in engineering. So in this class we have learnt all these things. I hope the concepts are clear. In the next class we'll discuss the further topics, and also we'll solve some numericals as well. Thank you all.